So today we're going to have a look at memory management. And this is an unavoidable topic in Rust. But I'm going to take maybe a slightly different approach to learning all of the complexity up front because I want to keep this project going. So let's cover the basics. There's this concept called ownership. And ownership has 3 rules. The 3 rules are that every value, like a variable, can only have one owner, which is the variable. And then if the owner goes out of scope, the value is freed from memory, but ownership can be transferred and moved around. So what that looks like is if we say, let's say we have S1, which is a string from hello. Maybe I'll leave autocomplete on since this is more conceptual today. And then we say S2 is equal to S1. Then if we try and print S1 here, theoretically, we should have a problem. Value borrowed here after move. So you just can't do this in Rust. It's as simple as that. And the reason for this is a whole class of memory errors, something, C++, like it's beyond the understanding of a mere TypeScript developer. And I'm sure that once I spend a few hundred hours writing Rust applications, I will run into problems where I need to understand this at more depth. But right now, I'm building palindromes and like JSON parsers and string manipulation apps on the CLI, and I don't really need to know all of this stuff. All I need to know is if I try and do this, it's not going to work. Whereas if I do this, it works absolutely fine. So you can't do this. That's step 1. The second part to this, let's comment this out, is borrowing. So let S3 be string from world, okay. And then let's put it in a function called borrow demo, so that you don't think that's actually something. And then let's say print line S3. After borrow demo, we want to print it out S3. Okay. And then we have to define borrow demo. We're going to take in a singular piece of data, which is called a datum. And it's going to be a reference to a string. That's the and in front of the string, a reference to a string. And then it's going to print that datum out. Why am I getting the squigglies? That should be fine, no? Oh, sorry. I'm confusing console printing with the actual function. So I've specified that it can only take a reference. So if I try and pass in an actual variable, it's not going to work. I have to pass in a reference. And when I do that, after borrow world. So that works fine. So you can have references, which is ownership can be transferred. And if I weren't to do this, so if I was just to say string, and then try and run it, we can't do that because when you put it into this function, it's out of scope, or the scope changes, and S3 no longer exists. So that's borrowing. And then there's the variation of this where you have S4, let's go with this. But S4 is a mutable variable. And then let's do a mutate demo. And then the way that you refer to a borrowed mutable variable is andmute. So let's quickly define mutable demo. We will have to refer to the datum here, which is a mutable string, like so. And that should all work fine. Except that I forgot to put the word function on there. So now we run hello world. Now there are other ways to pass around data. And I'm going to copy this in because I don't fully understand these yet, but just so that when you see these, you know what we're talking about. So the first is lifetimes. And with lifetimes, inside this longest function, there is a type of syntax where you refer to the like a single tick above the A, and my understanding is that this means that this returned reference should live at least as long as both input references. Now, why and how and where is, I don't think we're quite there yet. But when you see this, it's this annotation means that this should explicitly live for as long as both of the input references, so that you don't accidentally return a reference that's already been freed up. So that's one, that's lifetimes. Then we have a couple more here. We have the box. And the box, again, I don't know why we would need to use this, but now we're entering the territory of smart pointers, and we're talking about allocating variables to the heap rather than just the stack. Again, I don't know why we want to do that, but when we see box, it just means create some temporary space in a different place than where it usually goes for some reason that we don't need to know. And then if we want to go even further down the rabbit hole, we have reference counterpointers. And then let's just chuck it all in now. I believe there's also something called arcs, which I haven't even bothered to get into. And then you have ref cells, which is whatever this is, but with mutability. And in order for that to work, we even have to like import new stuff from up here. And I just want to check that all of this works, and it does. And I'm going to leave this here, and it's up to you if you want to go through it and go through the book as well and understand why it is. But I'm going to propose a radically different way of approaching all of this, and that is to, let's see, give me a second. I have a really beautiful video from No Boilerplate.
It says, use ownership and share nothing. Pass in some suggestions on how to learn lifetimes gradually. In order, 1, don't use references. Use ownership and share nothing. Pass in variables into functions, and if you need them later, return them back out, giving away ownership. 2, copy and clone everything. Rust is 80...
Don't use references. Copy and clone everything. And the idea is that once we get comfortable with Rust, then we can learn why we need to use references, why when it makes more sense, and when copy and cloning everything is no longer viable. So what I want to do is I want to show you how to first just ignore all of this for now, because we have no business getting into that on day 14 of a 15-minute each day program. Then just the basic stuff here, I want to show you how to do the very fundamental concept of ownership and borrowing without using references. So that when we see this stuff, as we go through future exercises, and we're pressed against it, we can just copy and clone everything instead, so that it all makes more sense. And there is a cost to that. The cost is that things will be imperceptibly slower, and my argument is that really doesn't matter at this stage. I think maintaining momentum and moving forward is more important. So, how would we handle this without borrowing? We just go s2 is equal to s1 dot clone, and then we can print s1 and there's absolutely no problem printing s1 because the ownership hasn't moved when you use the clone function. Sorry, that's my cat. Cat, please stop. Babadoo. Come on. Cargo run. Hello. Fantastic. So we just clone. Clone is the same as clone in JavaScript, so we're good. Then I want to clean. Okay, so that is the original example. I want to copy that out, and then I want to leave you with the cloned example. So then the next step is borrowing with this and reference. Which I guess we've kind of just done. Like, instead of passing in a reference, we would just go clone. And then the borrowed demo no longer contains a reference to a string, it contains an actual string. Borrow demo hello world. Now there is another way to do this, which I think is really interesting, and it's the first part of what he said, which is where you return everything. So inside borrow demo, instead of passing in a clone, what we can do is we can print how do we do this? So we can print out borrowed and datum, and then return datum. I think this should work. I don't know why there's a squiggly line there. So let's shadow it. Okay. So cloning is probably better because the compiler, TypeScript, everything is gonna be like, hey, you're probably not. So it cannot be formatted with the default formatter. I don't understand why. No. If I remove this, like, because the print line macro, my suspicion is that the print line macro is a new scope, and therefore datum is being destroyed. So does this work if I do that? Cannot be formatted with the standard formatter. Okay, so then this is getting more complicated than I intended. So I'm going to instead switch to clone. to make my point. And then all is good. And then we can just change this back there. Just clone everything. Perfect. If we want to do the third S4 variable now, because it's a mutable reference, we can just create let S5 equal to an S4 clone, and then you just mutate S5. As simple as that. And then if we go to the mutate demo, it no longer, it can still be a mutable reference as long as we mutate it. And I guess there are ways to do lifetimes box, RC, and refcell by just cloning things. But hopefully by the time that we need to do that, we will be more familiar with Rust, and we will start to understand why we would need to use smart pointers. And for now, I think just cloning and returning values is a simpler way for us to proceed to the next day. And that is going to be my approach.